Hello and welcome to INSY 2203 Networking Fundamentals. This is Instructor Davis. In this session, we will review interconnecting local area networks. As mentioned on the first slide, we will be reviewing interconnecting local area networks in this session. Specifically, we will take a look at the purpose for interconnecting local area networks, network bridges and network switches, routers, network interface configuration, and console port connection. The utility of local area networks led to the desire to connect two or more networks together. Interconnecting local area networks in a campus network, or even interconnecting local area networks in a wide area network, incorporate similar concepts and issues. The campus network is a collection of two or more interconnected local area networks. Either can be within a building or housed externally in multiple buildings. A bridge is used in computer networks to interconnect two local area networks together and separate network segments. A segment is a section of a network separated by bridges, switches, and routers. The bridge is a layer 2 device in the OSI model, meaning that it uses the MAC address information to make decisions regarding forwarding data packets. Only the data that needs to be sent across the bridge to the adjacent network segment is forwarded. An example of using a bridge to segment two Ethernets to local area networks is shown. The picture shows that local area network A connects to the port 1 of the bridge and local area network B connects to port 2 on the bridge. This creates two segments as shown in the picture. There are 4 computers in local area network A and 3 computers in local area network B. The bridges use the MAC addresses to build a bridging table of MAC addresses and port locations for hosts connected to the bridge ports. For example, if computer 1 in local area network A sends a message to computer 2, the bridge will store the MAC addresses of both computers and record that both of these computers are connected to port 1. The capability of a bridge to only forward data packets when there is an association is used to isolate data traffic in each segment. A potential problem with bridges has to do with the way broadcasts are handled. All broadcasts in a local area network will be forwarded to all hosts connected within the bridged local area networks. For example, the broadcast associated with an ARP will appear on all hosts. In the address resolution protocol, a broadcast is sent to all hosts in the local area network connected to the bridge. The bridge forwards all broadcasts. Therefore, an ARP requesting broadcasting the message who has the IP address is sent to all hosts on the local area network. The data packets associated with ARP requests are small, but it requires computer time to process each ARP request. Excessive amounts of broadcasts are forwarded by the bridge can lead to a broadcast storm, resulting in degraded network performance in terms of a network slowdown. The name for the type of bridge used to interconnect two local area networks running the same type of protocol is a transparent bridge. Bridges are also used to interconnect two local area networks that are operating two different networking protocols. For example, local area network A could be an Ethernet local area network, and local area network B could be a token ring. A common application today using a bridge is interconnecting local area networks using wireless technology. The use of wireless bridges in local area network is a popular choice for interconnecting local area networks when the cost of physically connecting the local area networks is prohibitive. The Layer 2 switch is an improved networking technology that addresses the issue of providing direct data connections, minimizing data collisions, and maximizing the use of a local area network's bandwidth. In other words, that improves the efficiency of the data transfer in the network. The switch operates at layer 2 of the OSI model, and therefore it uses the MAC or Ethernet addresses for making decisions for forwarding data packets. The switch monitors data traffic on its ports and collects MAC addresses information in the same way that the bridge does to build up a table of MAC addresses for the devices connected to its ports. The switch has multiple ports similar to the hub and can switch in any data connection from any port to any other port similar to the bridge. This is why the switch is sometimes called a multi-port bridge. The switch minimizes traffic congestion and isolates data traffic in the local area network. A managed switch is simply a network switch that allows the network administrator to monitor, configure, and manage certain network features such as what computers are allowed to access the local area network via the switch. The benefits of using a network switch are many in a modern computer network. These benefits include less network congestion, faster data transfers, and excellent manageability. It has been shown that a network switch can be used to replace the network hub, and the advantage is data traffic within a local area network is isolated. The term for this is isolating the collision domains, which is breaking the network into segments. A segment is a portion of the network where the data traffic from one part of the network is isolated from the other networking devices. Switches learn the MAC addresses of the connected networking by extracting the MAC address information from the headers of the Ethernet data packets. The switch will map the extracted MAC address to the port where the data packet came in. This information is stored on the CAM, or Content Addressable Memory. CAM is a table of MAC addresses and port mapping used by the switch to identify connected networking devices. Layer 3 switches work at the network layer of the OSI model and use IP addressing for making decisions to route a data packet for the best direction. Layer 3 switches are similar to routers in that they also work at layer 3 and use the network address for making routing decisions. Layer 4 switches operate at the transport layer of the OSI model. Layer 4 coordinates the communication between network systems. The Layer 4 switch identifies the application protocols included with each packet and can then hand off the packet to the appropriate higher level software. The router is also a network 3 device in the OSI model, which means the router uses a network address, the layer 3 addressing, to make routing decisions regarding forwarding the data packets. Remember, the OSI model separates the network responsibilities into different layers. In the OSI model, the layer 3 or network layer responsibilities include handling of the network address. The network address is also called a logical address rather than a physical address such as the MAC address. The logical address describes the IP address location of the network and the address location of the host in the network. Basically, the router is configured to know how to route data packets entering or exiting the local area network. This differs from the bridge and the layer 2 switch, which use the Ethernet address for making decisions regarding forwarding data packets and only know how to forward data to hosts physically connected to their ports. Routers are used to interconnect local area networks in a campus network. The networks can use the same protocol, e.g. Ethernet, or they can be used to interconnect local area networks that are using different layer 2 technologies such as Ethernet and token ring. Routers also make it possible to interconnect to local area networks around the country and the world and interconnect to many different networking protocols. Routers must have multiple port connections for connecting to the local area networks, and by definition, a router must have a minimum of 3 ports. The common symbol used to represent a router in a network drawing is provided. The arrows pointing in and out indicate that data enters and exits the routers through multiple ports. The router ports are bidirectional, meaning that data can enter and exit the same router port. Often the router ports are called the router interface, the physical connection where the router connects to the network. The console input is an input which provides an RS-232 serial connections link into the router for initial router configuration. This router is also showing a USB input. The auxiliary input is an input which is used to connect a dial-in modem into the router. The auxiliary port provides an alternate way to remotely log into the router if the network is down. This port also uses an RJ45 connection. The serial input is a serial connection which has a built-in CSU-/DSU. The interface is used to provide a T1 connection to the communications carrier. Note, the CSU/DSU function is presented in Chapter 10. This type of connection, the RJ45, replaces the older cabling using V.35 cable. The voice interface card is an interface which shows 4 phone line connections. This router can be programmed as a small PBX, a private branch exchange for use in a small office. The modem is an interface which has 2 RJ11 jacks and has 2 V90 analog internal modems. These modems can be used to handle both incoming and outgoing modem calls. The FSX DID is an interchange which has 4-part FSX and DID voice fax interface card. FXS is a foreign exchange interface that connects directly to a standard telephone. DID is direct inward dialing, is a feature that enables callers to directly call an extension on a PBX. In this diagram, router A connects directly to the local area network switch via fast Ethernet port FAO/0. Router A also connects directly to router B via the fast Ethernet port FA0/1 and connects to router C via fast Ethernet port FA0/2. Router B connects directly to the local area network B switch via fastband port FA0/0. Router B also connects to the local area network C switch via fast Ethernet port FA0/1. Router B connects directly to router A via fast Ethernet port FA/2 and connects to router C via fast break port FA/3. Router C connects directly to the local area network D switch via the fast Ethernet port FA0/0. Router C also connects to router A via fast Ethernet port FA0/2. Connection to router B is provided via fast Ethernet port FA0/1. Most modern internetworking technologies, example, hubs, switches, bridges, routers, now incorporate auto-negation protocol. The protocol enables the Ethernet equipment to automate many of the installation steps. This includes automatically configuring the operating speeds and the selection of full or half duplex operation for the data link. The auto-negation protocol is defined in the IEEE Ethernet standard 802.3x for fast Ethernet. In the illustration on your screen, each link partner shares or advertises its data link capabilities with the other link partner. Additionally, the two link partners then use the advertised capabilities to establish the fastest possible data link rate for both links. For example, in the example of the link partners shown, Computer 1 advertises that its interface supports 10 base T, or 10 megabits per second. The switch advertises that it supports both 10 base T and 100 base TX, 100 megabits per second. The network interfaces on each link partner are set for auto-negotiation. Therefore, 10 base T operating mode is selected. This is the fastest data rate that can be used in this data link. The data rate is limited by the 10 base T capabilities of the computer's network interface. Auto-negotiation takes place when an Ethernet link is established. The link information is only set one time. When the link is established, the negotiated link configuration will remain until the link is broken or the interfaces are reconfigured. The auto-negotiation protocol uses a fast link pulse to carry the information between each end of a data link. The data rate for the fast link pulses in 10 megabits per second, the same as 10 base T. The fast link pulses were designed to operate over the limited bandwidth supported by Cat3 cabling. Modern network interfaces for computer networks have the capability of running the data over the links in either full or half duplex mode. Full duplex means that the communications device can transmit and receive at the same time. In full duplex operation, the media must have separate transmit and receive paths. This is provided in a 10 base T signals with pairs 1 through 2 transmit and pairs 3 through 6 receive. The remaining pins configurations are listed. An important note is that the full duplex mode in computers network links is only for point-to-point links. This means that there can be only two end stations on the link. The CSMA/CD protocol is turned off. Therefore, there can't be another networking device competing for use of link A. An example of networking devices that can run full duplexes are computers connected to a switch. The switch can be configured to run the full duplex mode. This also requires that each end station on the link must be configurable to run full duplex mode. In full duplex operation, CSMA/CD is turned off in computers 1 and 2, and the switch are transmitting and receiving at the same time. In half duplex mode, CSMA/CD is turned on. Computer 1 is transmitting and computer 2 is listening or receiving the data transmission. At the same time, in half duplex operation, the link uses CSMA/CD protocol. This means that the only one device talks at a time, and while the one device is talking, the other networking devices listen to the network traffic. The router's console port is used as the initial interface for configuring the router. It is a slow-speed serial communications link and is the only way to communicate with the router until the router interfaces have been configured. Specifically, the console connections is an RS-232 serial communications port that uses an RJ45 jack to connect to its interface. The RJ232 protocol running on the console port is the same communications protocol format used on a computer's COM1, CAM2 port. However, the connector for the serial communications port on the computer is either a DB9 or DB25 type of connector. The DB25 serial connection is seldom used. A serial communication software package such as Microsoft's Hyperterminal can be used for establishing the communications link to the router's console input. The settings for the serial interface on Cisco's console port are provided. In this session, we reviewed interconnecting local area networks, including purpose for interconnecting local area networks, network bridges, network switches, routers, network interface configuration, and console port connection. As always, if you have any questions on this session, feel free to post in the Q&A forum or send me a message via course messaging or by email. Thanks for watching, everybody, and have a great day.